throughout these demos, the function we've been using most consistently is the print function. It's kind of funny, really, because I don't use print usually when I'm doing my own little coding. The only time I really use it is for debugging so that I can kind of figure out what's going on in a program more easily. But for the day-to-day stuff, for the actual functioning of it, printing something to the screen really isn't something that's useful. Usually what I'm doing is saving something to a file or reading something in from a file or otherwise manipulating data, right? And so we're going to be looking at a whole bunch of ways that we can do that. In fact, later on we'll be using pandas to bring in data frames and doing all kinds of fun things that we can do with reading in various forms of files and data from the web. But we need to get our hands around the very basic idea of what are considered kind of file and file-like objects. So Python treats files as a kind of special sort of a variable, just like some of the other variables. And often people produce variables that are like files that you can treat like a file and read in from it, even though it's not a file on your file system on your computer. So we need to have at least a rough idea of how files are handled in Python. And the truth is, there's lots of different ways they're handled, but there's some fairly straightforward things we can do with reading and writing files. So let's create a little text file. Let's do it with using the with phrasing for doing this. There's, as I said, a bunch of ways we can do this. This is the more old-fashioned way is to use what's called a file handle and then use that throughout. But this is a little bit faster and a little less messy. So we're going to with open, which is the command to open up a file. We'll have to decide what we're going to name the file, and we'll call it, say, foo.txt. And we need to say how we want to open that. And if you look up here, we have the mode. This kind of gives us, as we're typing, what's expected next within this particular function. And they're looking for what we're supposed to do with this, or how we're supposed to open up this stream. And we're going to open this stream up for writing, which is a W. Okay. Now, there are other options. We'll run into reading in a minute. There's appending. There's also WB to read or write in binary rather than in text, whatever text means in this context. Usually I would just use F, but I will do that. This is another one like the I. I'm just so used to using F that I'm just going to use F as the file handle. And so what this says is what we're going to do with the actual command here is open foo.txt as F. So F is kind of our little handle that we put on a new file. Because this text document does not exist yet, it's actually going to create the document, and it's going to write into that. If the document already existed, it would wipe it out. The W command says to start from scratch. So be careful with that. If you put an A instead for append, it will add on whatever you write to the file after what already exists there. But if you do a W, it's going to wipe out that file and start from scratch. All right. So what are we going to do with that? Well, we're going to do F dot. So F is the object. It's the file handler. And we can do a bunch of things. Actually, we have a list of things we could do here. But we're going to write. And then we can write something to our file. Hello. Oops. I guess we could do hell file. But hello file. And we can do, remember that \n is a new line. How are things with you? Now, if we end this here, in other words, if this is the end of the code block, if from here we go straight down and I guess we could, since we've been using print, we could say print all done, right? As soon as we get out of this while block, or sorry, not while, but with block, as soon as we get out of the things that are indented from the with, it actually closes out this file. So when you do it other ways, you actually have to say f.close. You actually have to do that method. But here, all we have to do is the write method. And as soon as we're done with it, basically once you get out of the indented text from the with, it closes out that file and assumes that you're not working with that file anymore for the moment. So let's go ahead and run this. Now all it's done to our screen is all done, right? But if we go up here, the question is where this puts, since we didn't say anything other than foo.txt. So what it's going to do is put it in the active directory in whatever system you're using. If you were on a system, you could give a full absolute file name. So you could say, for example, if you were on a Windows machine, c:/foo.txt. Mind you, there is some weirdness there with Windows, that Windows likes backslashes for some reason for its directories, but for Python, you just always use forward slashes because we use backslashes for something else, right? For our \n here. So you do a / if you did c:/foo, it would put it right up at the top of your directory structure. But when you don't have anything, if you just have the file name, it's just going to put it in whatever directory is active. Now on our virtual machine, we actually have files here, and you'll see that it's created this new file, foo.txt, and we can open it real quick. And you'll see that it says, hello file, how are things with you? So it's actually written out this file just like we would have expected it to. So awesome. Now that we have a file there, we could, if we like, go ahead and read the stuff back in. And I could do the same thing. I could do with open foo.txt and then do R instead of W, but I'm going to do an even shorter shorthand here. I'm going to do all the text is equal to, oops, I can do this, is equal to open foo.txt, and then we're going to be reading this. And then with that, I'm actually going to do the method right away, which is read. So what this says is that it's a method to read everything out of the text that I've just opened. And in this case, because all I do is the open and then the read, it's going to be fine. It'll be closed. It doesn't have a handle or on anything. So it's just going to open it, read all the stuff, put it in this variable here. This is going to be a string right here. And if it works right, boom. It won't actually say anything because there's nothing to say. But we can now see if there's anything in all the text. Oops. And we have the file. Now note that the file there is with the new line in it. Even though when we opened it up, it was 2 lines. It's all going to load up as one very long string when you read in a file like this. If you don't want to read the whole thing, you can say how many characters you want to read in. But if you don't put anything inside here, it just assumes you want to read the whole thing. If it's a very large file, that could be problematic, of course. But for this very short file, it's not a problem. Usually this is what you do, right? You read it in just like that. There is another piece that you might sometimes use, which is, and I think I have used this in the past, but it's fairly rare, which I can do. I'm actually going to copy paste this real quick, just to save myself from making more embarrassing typing errors. So we'll do, instead of all the text, all the lines, right? And instead of doing read, we'll do read lines. Now instead of giving me a very large string here, it's going to instead give me a well, we'll see. Now if we take a look at this one, all lines, you'll see that in this case we get 2 lines as strings in a list. So instead of reading it in as one single string, it makes a new list and puts it in this variable, becomes a list. And in the list you get 1 line for each line. You get each item is a single line. So that's another way you might read things in. Now, actually, we're kind of a little bit hamstrung here because we're using Colab. There is a way, if I open this file up, to upload large files. But what if I didn't want to deal with that? What if I wanted to open up a file directly from the World Wide Web. I can do that. I need to import some modules for that. OS, which is a built-in module that does all sorts of different things. It's for interacting with the operating system. And then we're going to import URL-lib request, which is a module for dealing with URLs or URIs, which are the HTTP thingies that you use to get connected to resources on the web. So let's do with, this is going to look very much like the one up above, URL lib request. I could have done that because I'm only going to use one thing in this. URL open. And then we're going to open something up with this. And as F again. We can reuse F because we're done with it up above. And what I'm going to do is, this is Project Gutenberg, which is awesome, which was one very early on in digitizing lots of out of copyright works. And we're going to take a look at the plain text version of Alice in Wonderland. And I'm going to figure out what that link location is and copy it. And I'll use that here as the URL we're going to open. So we're good with that, and then we can do the same thing we did before. We'll even kind of say all the text again. All the text equals, and this F, we're going to treat it exactly like we did above. So if we look up here, we have, oh no, we didn't. We didn't do it this way. We did it with open. We could have done it that way as well, but we've done it this way, so we're going to keep going. So I could have followed the same pattern I did here with using, instead of open, I would just have had URL lib request URL open, but here I've already done it this way. This works just as easily, and we'll just do a read. Okay, so what this does is it has the same file handle, right? It treats this just like a file, even though it's in fact it is a file. It just happens to be out on the web via URL. So if we run this, hopefully it will be happy with that. It's thinking for a while. Okay, it's all done thinking. Let's take a look and see what we have in all the text. So this is a very long, that's the entire book that it's output there. We could figure out some things about this. For example, we could find out how often the word Alice oops, not Alex. That would be a 0. Alice shows up in the Alice in Wonderland book. Ooh, it's not happy with that. So if we look here, it says it's a type error. It's a little confusing. The reason is that this is, if we go back and look, it will say that it's UTF-8, which is a way of encoding text. And it's read this in not as ASCII, but not as straight strings, but as bytes, byte-like objects. This used to be, frankly, a huge headache for Python, but in the later versions, they've managed to clean it up so that you can save yourself just by saying that you're looking for the byte string of Alice. This should work. So 402 times, whereas I believe Dodo is in the first one, right? Because of the caucus race. If we look for Dodo, it only shows up 13 times. So we can kind of do some basic stats. We could actually, if we wanted to, what we could do is break down all the words and see what the frequency of them are, right? Or we could look for, later on when we talk about regular expressions, we could look for all of the proper nouns and see how many of them are. Or we could see how many words there are altogether. How would we do that? Well, that process of finding words within text is called lemmatizing. But we can do a cheap way of doing it, which is, this is going to be ugly, but just so you know what it is, this is the split method is something you can use with text, right? And if you don't include anything here, it assumes that so what split does is it takes a string and splits it into a list, but it splits it along particular characters. So for example, I could do commas, right? And it would split it into things in commas. This is for a comma separated file, for example. Or I could do spaces. That might work here if I were doing spaces, but the truth is that sometimes there's differences in words that are not blocked by spaces. It can be differences between paragraphs, for example, and it would not see that as a space. So by leaving it empty here, it actually looks for any white space. Actually, I might say that here. Split on ASCII white space characters. So it will split on space, tab, return, new line, form feed, and vertical tab. So it'll split any of those things that create white space, it'll split it out. So if I do that, oops, it's running it. This is the list that it comes up with, which is a very long list of every single word. And that one's, these are bytecodes for like quotation marks and things like that. That's what the backslashes are there. But it basically breaks it down into the number of words. So if we wanted to know how long Alice in Wonderland was, we could quickly just do a length of this list, because it's a list of all the words in there, right? We could also, we could make sure that there were a unique, so it's 29,000 words. It's a fairly short book. We could make sure, we could go through and we could count the number of unique words. The way we would do that is by converting this into a sequence where you, or a set rather than where you could, sets are lists like objects, but you can't have more than one of the same object in a set. So we could convert it into that, and then we would find out how many duplicates we have in there and kind of deduplicate. But to do that, we'd actually have to do a little bit more work to do what I'd said before, which is lemmatize, because we want to get rid of some of those punctuation marks and other things that are in there that are messy. We're already starting to talk about the messiness, which is a lot of what data wrangling is, figuring out how you can get down to brass tacks and what's getting in your way of getting to that. So there's lots of other things we could do with this text, but we've done kind of the basics here. We've written and read the text. I'm going to briefly introduce the idea of pickle. There is a way of writing. So the problem with a program is that as soon as you're done, all the variables disappear, right? So what you could do is write out the output of your program. But what if there's things you want to save for the next time? There's a module called Pickle which lets you do that, and I actually use that even though I don't use it for major outputs, because it's only usable by a Python script, because you kind of bring it back in and you sort of desalinate, no, that's not the word I'm looking for, desiccate this, and then you can kind of bring it back to life by rehydrating it. That's what I was looking for, dehydrating. So it's like dehydrating these, storing them for a little bit in a file, and then you can rehydrate those variables when you open up another program. So Pickle is useful there. There's lots of file-like and file-helping libraries, modules and such, but the basics of being able to read and write a stream variable, a handle on a stream variable, is useful, because as we move into other things, you'll find that there are lots of libraries that treat things that you wouldn't expect necessarily to be thought of as a file. They kind of pretend it's like a file. So there's lots of file-like interactions, even if you're not reading and writing files. Honestly, though, you also have to be able to do that, right? The whole point of being able to handle this data is being able to bring it in one format, munge it around, and get it spat back out in a different format. All right, but for now, we'll leave it at that. And when we come back and we use pandas, it will kind of handle a lot of these pieces for us. And there's other libraries that do something similar.